So to move on with our topic which is ongoing and which is titled as hashing, our today's agenda will be, we'll be covering various types of hash functions, what actually a hash function is and what are the kind of key properties of these hash functions that we have already covered in our previous lectures. So if we talk about the hash function, it is a kind of mathematical operation that takes which takes an input or which takes a key and output a fixed size result, which is known as hash code or hash value. Key properties of hash functions are that these should be deterministic, must always generate a fixed size output. They should be efficient enough to process the input quickly and must be kind of uniform. That means the hash function should distribute the hash values uniformly in the hash table. They should be pre-image resistance, they should be collision resistant and must have avalanche effect. So with this background, let us move forward with the types of hash functions. So we can have various types of hash functions. Some of the common are listed here. So the first hash function which we will be covering is division method. Then we have multiplication method. Third in the list is mid square method. Then we have folding method. We have cryptographic hash functions. We also have universal hashing, and then we have perfect hashing. So these are kind of types of hash functions which we are going to cover in detail in our today's lecture. So let us begin with the first one, which is kind of also very kind of simple, and that is the division method. So division method involves dividing the key by a prime number and using the remainder as the hash value. So this division method is actually a type of hash function. So that function or that mathematical operation which is to be which is to be done on the key, and you will get a hash value. So in this division method, we divide the key by a prime number and use the remainder as the hash value. So we can describe this division function or division method as h of k is equals to k of mod m, where k is the key and m is the prime number, and h of k is the way of h, and then within the bracket k is something, it is a way in which we are going to write your kind of hash method or hash function. So hash function when operated on key k, we write it as h of k. So h of k is equals to k mod m, k is the key, m is the prime number. So you can see this is kind of very simple to implement, and it works well when m is a prime number. Now why do we need m to be a prime number? For the simple reason, if we are taking a mod from a number which is not prime, let us say that is a composite number. So for example, I am taking let us say 20 for example. So something mod 20 is going to kind of give me or value as 0 in many of the combinations we can say. But if m is a prime number, then it is going to generate different remainder for different values. So it works well when m is a prime number, but the disadvantage is the distribution is going to be very poor if m is not chosen carefully or if m is not chosen wisely. So choice of m is actually very important. As I have told you that it works well with a prime number. However, we can say the non-prime divisor, or if m is a composite number, that may work equally well as the prime divisors, provided they do not have the prime factors less than 20, and this is actually kind of kind of a proven research which is written in a particular paper which was kind of published by Lum and the co-authors in 1971. So non-prime divisors will also work equally well as that of the prime divisors. provided they do not have prime factors less than 20. So, prime factors more than 20. So, prime divisors as well as non-prime divisors will kind of work equally well, we can say. Also, the question comes up that when to use this division method. Usually it is going to be a preferred choice for the hash functions if very little known, if very little information is there about the keys, or if very little is known about the keys. So, the simplest one is your kind of division method. Then apart from division method, we have the next one in the list is multiplication method. So, in this multiplication method, we are going to choose a constant which is named as a, and this constant is going to be any value between any real value, obviously between 0 and 1. So, for example, 0.61803 is something which is given as the value of a, and this constant a is multiplied with the key. So, basically we have kind of 2-3 steps to be calculated in this multiplication method. First of all, we choose an a value between 0 and 1, then we multiplied that key value with this a, and the fractional part of the product is again then multiplied by m to get the hash value. Now, if you can see here on the screen, h of k is equals to floor m multiplied by k a mod 1, where if I am talking about k a, that is the simple multiplication of k, the key and the constant a, where k a, now k a mod 1. So, k a mod 1 means the fractional part of k, and this fractional part of k when kind of multiplied by m, then the floor of this whole expression is to be taken. So, h of k is equals to floor of m multiplied by k a mod 1. So, that is what my multiplication method is. The biggest advantage of this is it is less sensitive to the choice of m, just opposite to the division method, which was very sensitive to the choice of m. Disadvantages is obviously kind of a bit more complexity is being introduced in this as compared to the division method. So, we have seen a division method and the multiplication method. Moving forward, we are going to cover mid square method. Mid square, as the name suggests, the key is squared and the middle digits of the result are taken as the hash value, and if the key is string. So, for example, you can always square the integers, or you can always square the numbers, but if the key is a string, so key can be in the form of a string also. It has to be pre-produced to produce a number by using any of the any of the relevant or any of the use any of the methods, any of the general method, for example folding. So, folding is a method in which a string is pre-processed in order to produce a number. So, if you have a string, a number corresponding is pre-produced first and then it is squared, and middle digits are to be taken as the hash values. So, the steps are to square the key and to extract the middle digits of the squared value. Advantages, if we can see, it produces a good distribution of hash values, and good distribution is one of the desirable properties of a hash function. But because of its various steps which are involved, it may require some more computational effort, because you need to square the key, then you need to extract the middle digits of the squared value, and even if your key is actually is in the form of a string, first it has to be converted into the corresponding number. Why this is going to give you a good uniform distribution of hash values? Because your entire key participates in generating the address. So, the chances are higher that different addresses are generated for different keys. So, for example, let us say we have a key which is 3121. When we square it, we have got the number 9740641, and if we have the size of the table, let us say is 1000. So, for the 1000 cell table, h of 3121, if we take this h as a mid square function, we will be extracting middle digits of the square. So, we will be taking the middle 3 digits, leaving 97 from the left side and 41 from the right side. We will be taking 406, which is the middle part of 31212. So, this is actually the idea in which you are going to take your mid square function. Then we can always say, we can always take the binary representation of this bit string, which is 31212, and the binary representation here is starting from 1001010, that is available on the screen. You can have a look. We can always extract the middle part from this binary number, and that middle part which is being extracted is given here in a different color, which is 0101 000010. So, the middle part, the binary number is this, and this is equals to 322. This part can easily be extracted by using a masking operation and a shift operation. So, that is also one way of doing your mid square method, because you need to get your entire key participated in this. So, you square that, take out the middle part or middle digits, that is one way, or you can have a binary representation of that, and within that binary representation, whatever middle part you are going to choose, you can convert that into the decimal again. So, in this way you will be having your kind of mid square method. So, we have seen our division method, the simplest one. We have introduced a little bit of complexity, and we have got our multiplication method. As compared to multiplication method, we have one more a bit complicated method, more complicated method, which is mid square method. Moving forward, we have folding method. So, folding, as the name involves, it requires folding the key. How are we going to fold the key? Let us see. So, this folding method involves dividing the key into equal parts, then sum the parts, and then take the modulo with respect to m. So, what will be the steps? We need to divide the key into parts. Whatever parts are there, we need to sum them, and then we will be taking the modulo m of that kind of sum. Advantages, if we can say, are simple and easy to implement, and disadvantages is it heavily relies on the choice of partitioning scheme, that how are you going to kind of divide the key into parts. So, we will be looking this with the help of an example. So, for example, in India we have our Aadhaar numbers, which are exactly kind of 12 digit numbers, or in outside countries we have those SSN, social security numbers. So, for example, these social security numbers are in the form of 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have divided this social security number into a group of 3. So, as an example, we can also take a Aadhaar number and divide them into a group of 4. So, here we have 3 parts of this SSN, which are 1, 2, 3, 4, 5, 6 and 7, 8, 9. Then we need to sum all these 3 parts together. So, 123 plus 456 plus 789, all these parts when added together will give you the result as 1368. Now this 1368 is to be kind of divided modulo m, or we can say that T size. For example, if the size of the table is 1000, we can use first 3 digits as your kind of hash code or hash value. So this was actually a kind of we can say a very small example of using your folding method as the hash function, in which we have divided the key into several parts, process those parts using a simple operation such as addition. We just did it. So this was kind of one of the type of folding in which they are put underneath one another and then processed. So 1, 2, 3 added with 4, 5, 6 and then further added with 7, 8, 9, and this is basically what we call is your shift folding. Now apart from that, dividing the key, as I was telling you, that one of the disadvantages of this folding method is that it heavily relies upon the division method or separation method, in which through which we are going to separate the keys. We can this division can be done in many different ways. So for example, for the similar number which is starting from 1 ending to 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, we can always divide these numbers into 5 parts of 2 digits and the last digit remaining as 9. So we have 1, 2, 3, 4, 5, 6, 7, 8 and 9. Then we will add them and divide the result, which is modulo T size. So this was actually shift folding, in which your parts of the keys are actually we can say kept underneath each other and then processed using a simple method. Another kind of folding which is available as a type of this folding method is known as boundary folding. Boundary folding is something in which the key is seen as being written on a piece of paper that is folded on the borders between different parts of the keys, so that every other part will be put in the reverse order. Let us try to understand this with the help of an example. So we have 3 parts, let us say 1, 2, 3, 4, 5, 6. So first part 1, 2, 3 is taken in the same order. Then let us say the piece of paper with the second part is folded underneath, and we have instead of 4, 5, 6 we have 6, 5, 4, because we have folded that piece of paper on which the second part is written. So 1, 2, 3 is aligned with not with 4, 5, 6 but with 6, 5, 4, which is the second part in reverse order. And when the folding continues, 7, 8, 9 is aligned with the 2 previous parts. So basically we are kind of reversing, or we are kind of folding every other part or every alternate part. So the first part 1, 2, 3 we have kept as it is, 4, 5, 6 we have folded, so it becomes 6, 5, 4, and then 7, 8, 9 we have aligned it with the 2 previous parts. So the result will be 1, 2, 3 plus 6, 5, 4 plus 7, 8, 9. So the parts of the key is actually folded, kept underneath each other after kind of folding in a different manner, and then processed using a simple operation. For example, let us say we have addition, and we did it previously also. So this process is simple and fast, especially when we have bit patterns instead of numerical values. So in order to kind of shift them, we have in order to add them we have operations. So a bit oriented version of shift folding is obtained by applying the exclusive or XOR operation, in the case of strings, one approach could be to process all the characters of the string by XORing or by XORing them together and using the result for the address. So, for example, what I am trying to say here is, let us say we have a string ABCD and we divide that string into 4 different parts, A, B, C and D separate, and then these A, B, C, D or these strings are basically kind of XORed together. But if we divide or if we kind of segment the key in single digits, this method will result in the address between the numbers 0 and 127 only. So, for better results we can have chunks of strings to be XORed together rather than single characters. So, instead of A, B, C, D, we can have A, B together and C, D together, and then other parts of the obviously the key which is going to be large enough, I am assuming. So, A, B, then C, D, then E, F. So, chunks of strings are XORed together rather than single characters, and this is done in order to kind of generate a variety of hash functions which is going to be kind of collision resistant and uniform also. Moving further, we have one method apart from this folding, which is extraction. So, extraction says only a particular part of the key is used to compute the address, not the whole key. So, for example, we have our university roll numbers or maybe college roll numbers. So, these college roll numbers are actually starting with, let us say the college roll number is starting with 23. So, 23 is the year of the admission. Then we have 011, which is, let us say, or maybe 570, which is the code for computer science, and then the kind of roll number of the student, which is 01. So, this 23 and 570 is going to be common for all the students of computer science who have taken admission in 2023 year. Similarly, for the social security number 1, 2, 3, 4, 5, 6, 7, 8, 9, this method might use the first 4 digits, which is 1, 2, 3, 4, and the last 4 digits combined each other, giving some other combination that could be done. So, but each time only one portion of the key is to be used, and if this portion is carefully chosen, it can be sufficient for hashing, provided the omitted portion distinguishes the key only in an insignificant way. So, this is actually the example which I have just given you, 23/570. So, this 23/570 is going to kind of distinguish the keys in a very insignificant way, because this 23/570 is very, or it is common for all the students of computer science. Another example could be in some of the universities, all international students ID number starts with 999. So, the first digit can be safely omitted in case we are going to use extraction method as our hash function for computing the table position. So, if or another example could be the starting digits of the ISBN code is same for all books of a particular publisher. For example, let us say we are going to take any Teenage Learning or PHI or something of that sort. So, a single publishing company is going to give same code for the starting digits of the ISBN number. So, for example, we have 1133 or 2211, something of that sort. So, we can simply exclude these common numbers or common digits from the computation of address if a data table contains only books from one particular publisher. So, we can extract the significant part of our we can say key and then we can do some operations on that particular key. So that is what is the your extraction method. Moving further, we have radix transformation also. So radix, as you know, that is nothing but your kind of base. So the key k is transformed into another number base, that is we can say k is expressed in a numerical system using a different base or using a different radix. So for example, key is a decimal number 345 and its value in the nonal base or in the nonal system is 423. So nonal system is nothing but your base 9, and then we can divide this value modulo t size and use the resulting number as the address or as the kind of hash value. But we cannot say that collisions can be avoided up to a large extent, because we can have collisions here. For example, 345 and 245 are not hashed to the same location because they are different in the decimal number system. But if we talk about the nonal system, they can they both generate 23 when divided modulo 100. So collisions are actually kind of, we can say, we cannot avoid them. So in order to sum up in this lecture, we have started with some of the types of hash functions. We have seen division method, then we have seen multiplication, we have also seen mid square, we have also seen extraction method. Then apart from that, we have seen two types of folding methods, and then finally we looked into the radix transformation thing. More to more to this hashing in our upcoming lecture, which are universal hashing and perfect hashing, that will be taken up in our the next lecture. Here is a list of references which is being used for the preparation. I hope you have enjoyed one. I will see you in the next. Till then, take care. Goodbye.